Hello, my AP class. I am going to do this question for you guys because I saw some of you were still struggling with it, and I thought it might help to do a little video and kind of explain how this question goes. So we have a guy on a motorcycle. Each of these squares is 10 meters. So he starts from point A, takes 2 seconds to get here, goes all the way down in 5 seconds. That's 1, 2, 3, 4, 5, 6 blocks. That's 60 meters. And then another 30 there. And so that's his motion. He is moving in the x direction, in the negative x direction, in the negative y direction, then in the positive x direction. And so you could pretty see it's a straightforward graph right there. Now, keep in mind, displacement means change in position. We use x for position, so change in position is written as delta x. Change in position. Delta just means change in. It's just a fancy, sciencey word for saying change in something. So the change in anything is the final position minus the initial position. This is your displacement. Okay, now it could be yf minus yi. That would be your y displacement. And so that's basically how simply it goes. Now, our first question that they ask us on this is, what distance does the man travel going from point A to B? Now, that's really simple, right? 10 meters, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So 120 meters. That's your answer to part A. So A is 120 meters. They're asking for the distance, not the displacement, just the total distance that he traveled. You just add them up. Okay, next question states, what is the man's displacement once he reaches point B? So you can see that, what is his position here? He is at, I'd say, x equals 1 and y equals 3. Yeah, that's his initial position. His final position is x equals 1 and y equals negative 3. So final minus initial would be negative 3 minus negative 3. Now remember, that's 3 squares, so each square is 10 meters, so we'd write that as 10 meters, 10 meters, meters. So negative 30 meters minus negative 30 meters is negative 60 meters. And what you're saying here is your final position, your displacement, is negative 60 meters, meaning 60 meters below your original position. So that's your displacement. The x doesn't matter because we come back to the same x. Now, if the x been over here and we ended up here, you would be having this as your displacement, and you'd be using the Pythagorean to figure it out. But this was a simple question. The x value didn't change, it was just the y value. So your displacement should be written as negative 60 meters, where the negative is simply showing the direction. So you are negative 60 meters from where you were in the y direction. And so just putting negative 60 meters or 60 meters south each would mean the same thing. But that would be telling me not just how far I am, but what direction I am. And the negative sign again is just pointing direction. So that would be negative 60 meters for part B. That's A. Again, very easily can be calculated when you just keep this in front of you. Just know that the change is final minus initial. We don't care how you went. Even if he had gone all the way here and then gone here, maybe done a little dance out here and then come back here, the displacement would still be the same. It only depends on the final position and the initial position. It has nothing to do with what distance he traveled. Distance is an entirely different thing. Okay, let's look at the third question. What is the man's average speed? Now, I'd like you to keep these simple formulas in front of you, which is average speed is equal to total distance over total time. Average velocity is, I won't say total displacement because you don't add displacement, we use the word net displacement over total time. So if you have displacement, velocity is a piece of cake. All you got to do is make sure you find the right displacement, which we did. Another thing I'd like you to just keep in here is speed equals distance over time, and velocity is displacement over time. Now keep these in front of you while you're working through these questions so that you know what you have, what you're looking for. So our question says, what is the man's average speed? For speed, I need total distance over total time. Well, we found the total distance. The total distance was 120 meters. Well, let's just look at the total time. Well, that's 2 seconds and 5:7 and 5:12. So it took him 12 seconds. So 12 meters divided by 12 seconds gives you 10 meters per second. And that's all there is to it for part C. So let's put that down here. C is 10 meters per second. All right, our next question says, what is the magnitude of the man's average velocity for this travel? Now, magnitude just means it's a fancy word for size. What is the size of his velocity? How much was his velocity? They don't care about direction, and so they just want to know what was his magnitude of the velocity. So we can leave the direction out. Now remember, velocity, average velocity is total net displacement over total time. So we already found our net displacement, or our displacement was negative 60 meters, right? And our time is still the same, is 12 seconds. So 60 meters divided by 12 seconds gives me negative 5 meters per second. But again, this is where the word magnitude comes in. They don't care about the direction. This is just telling you that all the velocity was southwards. They don't care about the direction. They want the magnitude. They just want this part, the number. So 5 meters per second would be your correct answer. Had they asked for the average velocity only without using the word magnitude, then you would be saying negative 5 meters per second. That would be the average velocity. Okay, remember the sign, a negative velocity. If someone says my velocity is negative 5 meters per second, that just means I'm either going leftwards or downwards. Okay, the negative sign just means direction in terms of these things. So that's for that part. And then the last question is, what is the man's, I'll put that down, D is 5 meters per second. And now the last question is his instantaneous speed at t equals 11 seconds. Now, instantaneous speed is kind of like a trivial thing here, but I want to kind of get you to understand the concept. If an object is moving, and here's a position time graph, at a constant speed, you can see his slope is constant all throughout. So his instantaneous speed, which means his slope, will be the same everywhere. However, if my graph looks something like this, and I ask you, well, what is the instantaneous speed at t equals 1 second? It would be the slope at that point. Well, what is the speed at t equals 2 seconds? Well, that would be that point, because remember, the speed is just the slope, it's the rate of change. So instantaneous speed makes sense as a question normally when the speed is constantly changing. But in our question here, our speed stays a constant here. They want to know what is the speed when time equals 11 seconds. Well, that's 2, 5, so 11 seconds would be right here, right there. So what is the speed when he's over here? Well, we know what the speed is over here. It is this distance divided by this time. This distance is 10, 20, 30 meters. And this time is 5 seconds. So that gives me 6 meters per second. So his speed is 6 meters per second at t equals 11 seconds, which is right there. If I had asked at t equals 10 seconds, your answer would still be the same, 6 meters per second. If I would have asked for t equals 11.5 seconds, it'd still be the same, 6 meters per second, because this speed is constant here, okay? So I hope that helps you understand this. Let's put that down. E is 6 meters per second. And so here are your solutions. I hope that makes sense and helps you with further questions like this.